The second type of function we talked about this year was quadratic functions. And remember that quadratic functions have an x to the power of 2, and 2 is the highest degree, meaning 2 is the largest or greatest exponent in the entire polynomial. When we are talking about quadratic word problems, most times you're going to have to draw a picture because most times they're about rectangles. So this first example says that a rectangular picture has a width that is 2/3 its length. The picture has an area of 294 square inches. What are the dimensions of the picture? So we're going to draw a picture of a rectangle, and we're going to use the variable x. Remember that whenever you're doing a word problem, you need to pick one variable and stick with it. Don't label the width w and the length l or the base b and the height h. Pick one variable. You're going to do everything in one variable. So it says the width is 2/3 the length. So this side would be 2/3 the length, and this side would be the length. The area is 294. So we know that the formula for area is area equals width times length. So I'm going to have to multiply these together. The area, 294, is equal to the length times 2/3 the length. That could also be written with this in parentheses. You're going to distribute this L, so you get 294 equals 2/3, because there's a coefficient of 1 in front of this L. 1 times 2/3 is 2/3. L times L is L squared. Now, there are multiple ways you could solve this. You could solve it using the quadratic formula, but if you notice, we don't have a b value. You don't have a linear term because you have an L squared and you have a constant. So whenever you're missing your b value, the easiest way to complete the problem is to use the square root property, which means to get your squared term by itself to solve for the variable. So I'm going to just draw a line down my equal sign, and I'm going to multiply both sides by 3 to get rid of that fraction. We talked about that in the last packet, where whenever you have a fraction, if you multiply by the denominator, it cancels out the fraction. So 294 times 3 is 882. So 882 equals 2L squared. Now I'm going to divide by 2. 441 equals L squared. And we also talked about the inverse operation of something squared is the square root. So to cancel out that 2, I'm going to take the square root of both sides. So the square root of 441 is 21. So 21 equals L. So I know that L equals 21 inches. But now I need to figure out what W equals, because W is 2/3 of L. And if L is 21, I would do alpha y equals, enter, 2/3 times 21, and I get 14. So the width is 14 inches. And I could check my answer by doing 21 times 14, and I know that should be 294, because length times width gives you the area. Number 24, or the next quadratic word problem, says that Mr. Jackson had a rectangular shaped garden where the length was 2 less than twice the width. If the area of the garden was 40 square feet, find the dimensions of the garden. So once again, we are going to start with a picture. It tells us that the area is 40, so the length times the width has to be 40. In this word problem, they said the length was 2 less than twice the width. So you really have to think about what that means. 2 less than means minus 2. Twice means 2 times. So the length was 2W minus 2. So 2 less than twice the width. So read it very carefully. It's not 2 minus 2W. It's 2 less than 2W. And this side would be W. They don't tell us anything about the width. They just say the length was 2 less than twice the width. So this one's very similar to here, where we're going to say that area equals length times width. So 40 equals w times 2w minus 2. And we're just going to put that in parentheses so that we can see that we can easily distribute. So 40 equals 2w squared. W times 2w is 2w squared. You can put that coefficient if you need it. And then 1w times negative 2 is negative 2w. The difference between this problem and the last problem is this time you do have a linear term. You do have a variable with no exponent. What that means is you either have to factor it or use the quadratic formula. I'm a big fan of the quadratic formula. You guys know that. 1, because it's on your formula sheet. You don't have to remember anything. And 2, because it works all the time. Factoring sometimes doesn't work, but the quadratic formula works all the time, no matter what. So to use the quadratic formula, I have to get my equation equal to 0. I'm going to do that by subtracting 40 from both sides. So I get 0 equals, and then 40 is not a like term with 2w squared. 40 is not a like term with negative 2w, so this negative 40 becomes its own separate term. So I get 2w squared minus 2w minus 40. The next step in using the quadratic formula is to find your a, b, and c. So a equals 2, b equals negative 2, and c equals negative 40. Once I have my a, b, and c, I'm just going to plug it in to the quadratic formula, and every time I type it in for one of these variables, I have to remember to put it in parentheses. So I want you to imagine all of these variables in parentheses. So I have x equals negative 2. The reason why I have a double negative is this negative is in the formula, and then this negative is with my b. Plus and minus the square root of negative 2 squared minus 4ac all over 2a. Again, notice that every single time I plugged a number in for a variable, I put it in parentheses. That's going to be super important for this b right here, because if you forget the parentheses, it's going to throw everything off. So this one right here is the very, very most important. Alright, so now we're going to type this in. Start by doing a fraction. Alpha y equals enter. Negative 2 plus the square root of negative 2 squared minus 4c all over 2 times 2, and I get 5. When I do the minus, I get negative 4. Remember that when we're talking about lengths and widths and basically anything, it can't be negative. Time, it can't be negative. So I'm not going to use this negative 4. I'm going to use this 5. So x equals 5, or w equals 5. So that tells me that the width is 5, but now I have to solve for my length. So I'm going to plug 5 in for my expression down here. I have 2 times 5 minus 2, and I get 8. And I could check that. I could do my length times my width, 8 times 5, and I get an area of 40. So always double check your work. Make sure you didn't make any small mistakes before you move on. So here's my answers. Now, once again, we need to be able to recognize graphs. And because you have your graphing calculator, the best thing to do would be to use it and graph them in your graphing calculator and compare. Now, I want you to be able to notice some key features before you do that. Notice that your y-intercept is always your constant, and that is true for linear functions, quadratic functions, and exponential functions. My constant for this problem right here was 294. That's a very big number. My constant for this one was 40. That's a smaller number. So it's very obvious that the constant is more negative for this first problem than it was for the second problem. Now, if you wanted to graph it, you would go to your y equals menu, and you would graph your y equals. So you have to get it equal to 0. So I'm going to graph this one right here. So we have 2x squared, or 2w squared. your calculator only uses x. So even though we used a w in our problem, we're going to use an x on the calculator. Minus 2x, or minus 2w, minus 40, and I'm going to look at the graph. You're going to see that this graph and this graph don't look anything alike. The reason for that is because of the window. Quickly, I'm going to teach you how to change the window in your calculator, but it's not necessary. So window, it's going to ask for different values. My x minimum on this graph is negative 200. My x maximum is 200, and it goes up by 200. So every box is worth 200. My y minimum is negative 200. My y maximum is 400, and I'm going up again by 200s. Now when I look at my graph, it looks so much more like the graph given. So if you click window, you can change this information. Now if you change this information and you don't know what to do after that, clear out of it. So if you click second quit, clears out, and then reset your calculator. Second plus 712 resets the window back to the standard window size so that you don't have to worry about any other problems. Resetting your calculator is something that you need to be a master at before going into that test. So go ahead and reset your calculator right now.